Yes.
Supercapacitor is
Yes.
an energy storage devices. It delivers high specific capacitance and long life cycle and high energy density. The fast charging and recharging ability of supercapacitors have made it more attractive towards many industries. It plays an important role in the video recorders, TV satellite receivers, and alarm clocks, radio processors, controllers, home appliances, and solar panels. It's a it's a type of supercapacitor. Supercapacitors it consists of electric AA capacitors and hybrid supercapacitors and pseudocapacitors. It's a combination of hybrid supercapacitor and pseudocapacitor. It's a pseudocapacitor is basically absorbed ions. It's a working mechanisms of these supercapacitors, and this is a synthesis of molybdenum dioxide and iron oxide nanocomposites. It's 0.02 mole of molybdenum dioxide and 0.202 mole of iron oxide were mixed with 20 ml of isopropanol and sonicated for 1 hour. Then this mixture is centrifuged for 5 minutes at 5000 rpm. Then the precipitate was dried overnight and ground well for using mortar and pestle to form molybdenum dioxide and iron oxide nanocomposites. And this is a Electrode analysis is used to investigate the structure, purity, crystallinity of the prepared molybdenum dioxide, iron oxide, and these composites. Its peaks or peak shift, signifying and high purity nature and with perfect stereosymmetry. It's a FTR analysis. It's a broadband centered 3,446 centimeter power of -1 belongs to O bond H structuring and binding hydroxyl groups. And the interlayer water molecules exhibits the broadband of 1621 centimeter power of inverse. And furthermore, the two peaks 1092 and 564 centimeter power of -1 attribute the molecular vibrations and molybdenum and iron molybdenum bond O. It's figure 3. Moreover, the impurity peaks were found FTR spectra, confirming the high purity of molybdenum dioxide, iron oxide, and these composites. And this is a same images of molybdenum dioxide and iron oxide and its composites. Uh, Nanoplates were presented in this range 50 to 100 nanometers, and comparatively the particle size molybdenum dioxide and iron oxide nanocomposites is lower than molybdenum dioxide and iron oxide. With a large surface volume ratio provided good electrochemical activities. And this is a bit study Brunner Emmentaler method. This surface area is calculated 17.4, 43.26, and 123.82 meters squared by gram, respectively, in this figure. This is a electrochemical analysis. It's used CV and EAS GCD cyclovoltammetric and calculated the specific capacitance range 908 is the best range in this method. Its a potential window is 0 to 0.6 voltage is depicted. And electrochemical impedance spectroscopy is determined internal impedance and the capacitive nature of molybdenum dioxide, iron oxide, and these composites at a frequency ranges 100 kHz to 0.1 Hz, and obtained RS and RCT values is 0.48 ohm and 0.01 ohm respectively. And this shown in figure 8A respectively. RS and RCT molybdenum were determined is 0.8 ohm to ohm and 0.03 ohm respectively. RS and RCT Fu2O3 were calculated 0.58 ohm and 0.05 ohm respectively. GCD analysis, the discharge curve is molybdenum dioxide, iron oxide, and these composites are shown in GCD analysis, and the constant current density is 0.523 and the operating voltage is 0.04 voltage. The existence of nonlinear discharge patterns indicates the produced electrode materials as battery-like characteristics. Its synergistic effect of molybdenum dioxide and iron oxide improve redox activity when compared to individual molybdenum dioxide and this iron oxide and these composites. This is the cyclic stability molybdenum, and this composite cycling performance was tested at a current density 3 ampere by gram, and the electrode material demonstrate improved capacitance reduction 88.8% and after 3000 charge discharge cycle shown in figure. And this is a conclusion: the electrochemical characteristics of molybdenum dioxide and iron oxide nanocomposite in 3 molar aqueous KOH potassium hydroxide electrolyte were evaluated using a cost-effective and hydrothermal method. The XRD spectra indicate the produced material structure, phase, crystallinity, and purity according to the CV curve. The highest specific capacitance of and these composites 908 farad by gram. The EA spectra indicates the produced electrode material internal impedance, and which included decreased solution resistance and charge transfer resistance are 0.48 ohm and 0.01 ohm respectively, as well as excellent capacitive behavior. Further, the produced electrode retains roughly 88.8% capacitive charge after 3000 charge and discharge cycles. Thank you, sir.
This is my heading, sir. Topic: catalytic synthesis of carbon nanotubes using CeFeMgO efficiency and structural insights. Presented by D. Manikandan under the guidance of Dr. T. Somanathan, School of Basic Science, Department of Chemistry, Vistas, Chennai. Introduction, sir. Carbon nanotubes discovered by Sumio Ijima in 1991. Carbon nanotubes are allotropes of carbon. 50,000 thinner, 50,000 times thinner than a human hair at a nanotube, sir. Is stronger than steel per unit, sir. In emerging trend, carbon nanotubes in all field like material making, battery, grounding bridge, medicine, construction materials, sir, and etc. These are images, sir, single walled and multi-wall carbon nanotubes, sir. And aim objectives, sir, to study the catalytic investigate the synthesis of the carbon nanotubes using CeFeMgO structural insight into the CNTs. Objective: to synthesize the helical multi-wall carbon nanotubes by CVD deposition and purification to determine the percentage carbon yield to characterize the final product of helical multi-wall carbon nanotubes using XRD, FESM, EDOX, TEM porosimeter, Raman, TGA, and growth on CNT using CVD techniques. Need for the study: carbon nanotubes are primary non-material that have outstanding physical and mechanical characteristics. Can be combined with cement-based material to alter their heating characteristics. Carbon nanotubes forms and all the field like potential degradation, catalytic application, biology application, antifungal, antibacterial as biosensors. These are material and methods, sir. First step, synthesis of combustion catalyst. CeFeMgO is set. Molar solutions and added citric acid, ferric nitrate, cerium nitrate, magnesium nitrate, citric acid added. These are one molar solutions, sir. And added that solution 550 degrees Celsius maintained in muffled furnace. Combustion catalyst formed at 5 minutes. These are combustion catalyst I prepared, sir. And step 2, synthesis of carbon nanotube using CVD method to take the final product catalyst 100 mg loaded in core strip, retention time, nitrogen gas fast and 60 degrees Celsius, 10 minutes, and hydrogen gas and 640 days, 10 minutes spin gas, and final product I got it, sir. This is the result and discussion, sir. XRD pattern, multiple carbon over CeFeMgO catalyst. I got a peak XRD pattern peak at 26.03 degrees and 42.98 at 2 theta, sir. Ascending to 0.02 and 0.01 reflection of typical graphites. This evidence proves the absence of amorphous carbons. The intense peak gives a clearly indicates that the CNDs obtained are having good crystalline nature, sir. Exactly. And FSM images clearly indicates the formation of helical structure that the helical multiple carbon nanotubes
try to finish within 2
we are
minutes.
composed of 2 or 3 coil nanotubes connected to a
Manikandan.
catalyst nanoparticles, ABC. These are 10 helical multiple carbon cell images. The coil type and small coil type and 5 nanometer, 150.